So let's talk about Archimedes' principle. And Archimedes was a physicist, and he is attributed to this principle. And as the story goes, Archimedes was asked by the king that he had received a piece of gold, a piece of gold jewelry from Artseman. How do you pronounce that? Artsman. And this guy claimed that the jewelry was actually pure gold. But the king was suspicious about that, and he asked Archimedes to figure out a way in which he can figure out that the jewelry was actually pure gold and not some alloy. So Archimedes was in great puzzle how to solve this, and while he was pondering about this problem, he jumped into his swimming tub. And as he jumped into his swimming tub, he realized that actually the water was putting pressure on it. There was a force which was being applied by the water on his body. So Archimedes figured out that he has a way now to figure out whether the jewelry is gold or not, and he was so excited that he started shouting "Eureka, Eureka!" and he started running in his bath towel to the king. Well, Eureka means I found out, I found out. So let's talk about this Archimedes principle. So Archimedes principle is that if there is a fluid and you put let's say something inside the fluid, and because of this object, let's say this guy can float. This guy can float in the liquid, and because of this object, this mass here is going to displace this amount of volume of fluid. So whatever was here before was actually fluid, but now as you put the mass inside, the fluid has been displaced. It has been displaced from this position. So what Archimedes said was that the force applied by the fluid on the mass is equal to the displaced, or fluid is equal to the fluid displaced by the object. Okay, so if we have a boat and we put that boat in water, we know it displaces water. So amount of water displaced by this boat, let's say this amount, and this is the amount of force that fluid puts on the boat in the upward direction, and this is called B-O-Y-A-N-T, buoyant force. This is a buoyant force, and this is just in the upward direction, just opposite to gravity. Okay, so let's say if you have something that cannot really float on the fluid, it's heavy, like iron cannot float, just a block of iron cannot, a brick of iron cannot float in water. But even then, even if you cannot float on water, if the thing has submerged, even then there is a buoyant force upward. Now how much is this buoyant force? Well, you see, if the volume of this block is V, then buoyant force is going to be rho V G. This is the mass of the fluid displaced, where rho is the density of the fluid, times the volume of the fluid. The volume of the fluid displaced is nothing but the volume of the block itself. This is the mass of the fluid displaced, so rho V is mass of fluid displaced. I should have said equal to the weight of, so there should be weight of fluid displaced by the object. So mass of the fluid displaced rho V, and the weight will be nothing but rho V G. So this is the mass of the fluid displaced. Okay, wood can float on water because we know that wood has a lesser density than the block. So wood, if let's say displaces this amount of water, then we know, let's say, okay, let's take a small example here. Let's say wood has a density of 0.2 and has a volume V, and rho is 0.2 for the wood. There's a block. So what is the mass, or what is the weight of the wood, or the force of gravity of the wood? In fact, the force of gravity on the wood is going to be 0.2 Vg, right? Okay, and how much volume of water needs to be displaced to balance this Fg? Well, this is the force, this is the weight of water that needs to be displaced, so that I should have written the units here. This is gram per centimeter cube. Okay, so this is the weight of water that needs to be displaced, because if we make a free body diagram, there's 0.2 Vg and upward is buoyant force. So these two should be same, only then should be equal, only then the wood will float on the liquid. So 0.2 Vg should be equal to the volume of, let's say, water displaced, call it Vd. So Vd is volume of water displaced, and we know density of wood is density of water is 1. So rho W is 1 gram per centimeter cube. So Vd times 1 gives us the mass of the water times weight, we get G multiplied by G. Okay, G gets cancelled and we get Vd equals 0.2 V. So 20% of the volume of the wood gets submerged in the water, and because of that the buoyant force becomes equal to the force of gravity on the wood. That's why wood can float. But this cannot be true with iron, because even you submerge the whole iron, still the force of gravity is more than buoyant force. So iron cannot float on water, but iron can float on mercury. So if you have a solid block, the principle is, if you have a solid block of something, if this is rho 1, this is rho 2, rho 1 should be less than rho 2, only then the block can float. For boat it's different. Boat is different. It's not a solid block, but the way boat has been designed is such that it displaces a mass of water or weight of water, such that the buoyant force is more than, or at least equal to the force of gravity acting on the whole boat.